Hello everybody and welcome back. We're taking a look at the 2004 Grade 8 Gauss contest, and we're looking at question number 23 in this video. So thank you for joining me, and let's take a look. Question 23. In the diagram, the value of x is... Okay, so we have a bit of a diagram going on here, triangle A, B, C, D, E. We have x degrees right up here at angle DEB. We have some other angles, 30 and 80 degrees labeled, and then we have lines through some of these lengths. Okay, so that means that AE is the same length as CD, and DA is the same length as EB. So hopefully that'll help us work some of this out. Let's redraw our picture in our notebook. There we go, not a bad drawing. A, B, C. So we have a triangle here. We know we've got 80 degrees. Okay, and then at some point, some distance up here, we can connect. We get 30 degrees here. And this length and this length are the same. This length and this length are the same. And we want to figure out x degrees. Okay. What are we to do? And I think these are called D and E. So I can notice that AE is the same as CD, the same length, and AD is the same as EB. We can actually use this information to show that AC and AB are the same length, and that means this is going to be an equilateral triangle. So we're going to get an 80 degrees over here. So what I can say is AB, well, that's the same as AE plus EB, but that's the same as CD plus DA, and that's the same length as AC. So it is isosceles, and we do get an 80 degrees over here. More than that, we can now work out this angle up here, A. What I'm trying to do is just fill in the information that I know. I'm never going to be able to tell what AE is as a length, but I can certainly work out some of the other angles here. Just gaining more knowledge, chasing the diagram around, we can often either reveal the answer to us. We work out enough angles, maybe eventually we'll work out angle X. Or it can at least provide us enough information to say, oh, that's connected to that. We can use these two pieces of information or view this as the same thing two different ways and give us a plan of attack for finding out what X is. Okay, right now I don't know exactly how I'm going to find out what X is, but I can complete more of my picture and maybe it'll reveal itself to me. Okay. So I'm going to figure out the angle at A. I know the sum of the angles in our triangle has to be 180. So 180 is 2 copies of 80. Plus the angle up at A, and then I've represented that by a dot. So we get 160 plus dot. Doesn't take too long to see dot is 20 degrees. So we have 20 degrees, we have 30 degrees, and at last, the way forward, the way of calculating x reveals itself. If you have any triangle, and I know the inside, 2 of the inside angles, and I extend a line beyond the triangle, then the exterior angle is just going to be the sum of the 2 interior angles. This is just a nice triangle rule. If you don't want to do it that way, you can say, okay, I've got the 20, I've got the 30, I can figure out this angle here is 130 degrees, and then I can figure out the angle AED and DEB have to add up to 180 degrees, and so the x will be 50. But this is just a shorter way of doing it, and it's something you should know. And because it's shorter, it can often mean finishing a question or two a little quicker, and that gives you more time on the harder questions. We still have 24 and 25 to do, so maybe we'd like as much time as possible. Okay. So using this rule, we can see x is going to have to be 20 degrees plus 30 degrees, and that gives us x is 50 degrees. So 50 degrees, is that one of the answers? Geez, I hope it is. Yeah, C. Okay, I'm going to flip the page in anticipation of our penultimate question, question 24. Thank you guys for watching, and I'll see you in the next video.